Hello, everyone. I'm Eric Cox. I'm a member of the Netcapital team. Let's allow 1 minute for everybody to settle in. Thank you. All right, it looks like folks are still trickling in, but we had a little bit of some technical issues getting started, so we're a couple moments in. Let's go ahead and get started here. Hello again, welcome. Today, I'm excited to welcome Brad Larson with Avadain. As always, this company is actively raising capital on the Netcapital platform. I'm gonna go ahead and add a link to that into the chat feature here. A few quick housekeeping items while I do that. Please do use the Q&A feature built into Zoom. I know there's also a chat feature. I'm going to use that to share some resources during the conversation, but please do use the Q&A. It makes it so much easier to track the questions as they come in. I really do want to get to as many of those questions as possible. So please ask your questions. We want to keep this interactive, but please do use the Q&A feature. And I went ahead and added the link to the offering page into the chat feature just now. But with all that being said, please join me in welcoming Avadain to the screen here. Brad, why don't you tell us a little bit about yourself and what you're building with Avadain?
Great, thanks, Eric. I'm Brad Larson, the CEO of Avadain, and I came across this opportunity in 2016 when I was asked by the Fraunhofer Institute for Applied Solid-State Physics to come and look at an idea they had for creating the supermaterial graphene. And I had a relationship with Fraunhofer because we have been working with them since 2011 as part of a company that I was with called Bastille that licensed and commercialized technologies from universities and research institutions all over the world. But I was frankly blown away when I heard the ideas that the researchers put forward there in Germany in 2016. Graphene was discovered in 2004. In 2010, there was a gold rush. By 2017, the gold rush went bust because three problems existed: the quality of the flakes, the quantity, and the price. And these researchers at Fraunhofer came up with what they thought was an idea how to overcome those. And so since 2016, my colleagues and I have been working on developing this technology, and we're now at the point where we can bring this to the public through Netcapital.
Thank you so much for that. And for those who are not that familiar with the graphene space altogether, what is the problem? And then if you want to specifically address the problem first and come back to the solution, you can, or if you want to tie them together, what's the problem and what is the Avadain solution?
Great question, Eric, thanks. Graphene is perhaps the most disruptive material of all time. You don't make something out of graphene, you add graphene to make things better. And the problem is the three obstacles that I just spoke about. There are hundreds, thousands of uses for graphene, but no one has been able to make it with very high quality. The other problem is that no one has been able to mass produce graphene. People do it in a lab, they make a few grams. It's very, very difficult to make using mechanical and manual methods. And then finally, the price. To make graphene flakes of the quality that we have typically could cost $1,000 a gram, maybe $3,000 a gram. It's all hand done. So those are the problems. The solution is what the Fraunhofer researchers found, and that is the use of electrochemical exfoliation, a very well-known process, but it's never really been applied to graphene in an effective way before. The use of electrochemical exfoliation and expansion to separate the layers of graphite, the core material of graphene is graphite, into single atomic layers. Those atomic layers take on a very unique set of characteristics, And that's what graphene is. So the use of electrochemical exfoliation and expansion in an oxygen-free environment creates very high quality graphene flakes.
That was super helpful. And for those who aren't familiar with your background, tell us a little bit about yourself, who you, Brad, and then let's go into some of the other key team members as well.
Sure, absolutely. I am an international lawyer by training. I haven't practiced law since 1991. At that time, I decided that I wanted to be an entrepreneur and not a Wall Street lawyer. So I moved to London and started my first company in a licensing deal with Buckingham Palace. We had the right to sell as a collection the goods that the royal family endorsed as the best of British. And we did that as a department store within a department store theme in Japan. And then we brought it over to the United States as a catalog company. We sold that towards the end of the 90s. And then I began getting into high-tech solutions for the trucking and logistics industry. And in the course of that, began working with the US's #1 IP law firm, Fish & Richardson. We did a number of transactions. In 2005, we wound up acquiring a patent portfolio in connection with one of the products we were developing. It turned out that that patent portfolio was fundamental to the US cellular networks. We then switched into technology licensing, and that was quite a successful venture. And then in 2010, Fish & Richardson suggested that we form the company I mentioned earlier, Bastille, in which we would partner to represent universities and research institutions all over the world to identify at a very early stage technologies that could be disruptive, to patent those technologies, to create the business plan, in some cases to provide the R&D funding through third parties in that, and then to commercialize those technologies. And in the course of that, we came across the graphene technology we're talking about today. Now, for other members of the team, Phil Van Wormer is a chemical engineer. He started his early career at DuPont Advanced Materials. He then went on to senior leadership positions at a few Fortune 1000 companies, including GE. And lately, we've been doing deals together on and off since the late 90s. Lately, he's been involved in the electric vehicle space, which is very helpful for what we're doing. Phil came in on this project in 2019. He's a core member of the team. Erica Wojak, who I'm not only married to, but have worked with since 1993, is our CFO and COO, which is a good thing for our shareholders because as a lawyer, I find it sometimes difficult to add or to remember where the zeros go. Anyway, Erica is an expert at not only finance and cash management for startups, but also on valuation analysis. Her background was with Peterson Consulting, where she was doing valuation analysis. And Ryan Tien, who's one of the members of our science team, our chief science officer. He teaches at the University of Arkansas. He has a great specialization in nanotechnologies. But more than that, Ryan has a very unique blend of characteristics that make him very business oriented. He understands the direct connection between the science and business. And then finally, last but not least, is Sarah Rocha. Sarah is now consulting for us as a graphene scientist. She is actually the lead inventor from Fraunhofer who worked on perfecting this technology. And once we're up and running and we can afford to bring her over full time, we'll be doing that. So that's the core team.
I love digging into the team. Thanks so much for that. And what a great way to expand the team strategically through marriage. So taking notes out there, attendees, if you need to add in a CFO, that's a surefire way. No, I joke around. So we definitely talked about the Fraunhofer development. and a little bit of how this was discovered. What was the reaction to this discovery when we started learning about graphene? And then we want to dig into like what are some of the use cases for graphene?
Graphene is to our century what plastics was to the last century. And that is just an almost inconceivable array of products can be made better, lighter, more functional by adding graphene. Some of the core areas are renewable energy, electric vehicles, commercial aviation, space exploration, medicine, and water filtration. Those are just some of the areas. With renewable energy, graphene has been proven to be able to improve the density of battery storage. It has been able to help to make the charge and discharge faster, and it has been able to make batteries lighter. Those are just a few of the energy storage areas. In terms of aviation, Richard Branson, who's one of the chief proponents for the use of graphene, wants to see graphene used in the body of the aircraft to be molded in with the composite material to de-weight the aircraft. So instead of using, X number of layers, you can use 1/2 the X number of layers, make the airplane stronger, but much lighter, so that we reduce the carbon footprint and also allow the plane to fly further between destinations. And in the area of water purification, graphene is being used in, for example, Australia to purify seawater into fresh drinking water. Those are just a few of the many applications of graphene.
Yeah, that is a wide array of applications. And I do love the aerospace, the military application. Anytime you can make things lighter and stronger, there's an environmental impact. And I know that's super relevant right now. So why hasn't graphene changed the world yet? What's holding up adoption and progress here?
Right. I love watching these YouTube videos that science reporters make on graphene, and they almost all end with, and someday the promise of graphene will be here with us when people can make enough of it at an affordable price. That's why graphene hasn't really been adopted. There just isn't a commercially available source of large, thin, and defect-free graphene flakes in industrial quantities at an affordable price. There are a lot of suboptimal materials that people call graphene, and it causes a lot of confusion in the marketplace. But that's not what we're talking about. You can buy suboptimal quality graphene from China by the boatload, but it won't have the remarkable qualities that graphene has today.
Got it. No, that's an important factor for sure. And I love that questions already coming in. So I'm going to start peppering these in to some of the prepared questions we've had. So somebody wants to circle back. What is the relationship between Avadain and Braunhofer?
Fraunhofer completed their work in 2020, and they are then done with this project. They're an R&D institution, and they completed the project. That's it. They transferred the patents and the equipment to us, and we have given them a 2% royalty off of sales of net revenue, of gross revenue that we generate.
Perfect. No, thanks for that. And then can you tell us about some of your major milestones, and the timeline for those milestones?
Sure, absolutely. The first milestone was getting Panasonic Corporation to invest in the R&D for Fraunhofer. Panasonic is the one who largely paid for the upscaling, the creation of the technology. So I would say that was milestone number one. Milestone number two was in 2020 when Fraunhofer demonstrated that it could, in a lab, reliably produce this very high quality graphene with a high yield. And that was a huge milestone. Milestone 3 was the transfer of the IP, the patents, the equipment to Avadain and the creation of Avadain. Milestone 4 is having gotten patents. That cannot be stressed enough how important that is. We have patents. The original patent was granted in 10 countries, including the US, Japan, and Germany. It's pending in 9 countries, and we have 2 other patents that are pending in 19 countries. So we have a really great patent portfolio to protect our technology and to serve as the basis for revenue generation through licensing. The next milestone was forming an alliance with the Rapid Manufacturing Institute. Rapid is part of the Manufacturing USA network, which was created under the Obama administration to help make US businesses, and particularly small and startup businesses, more competitive. Each Manufacturing USA Institute is a joint venture between a department of the government and a private sector organization. Rapid is the Chemical Engineering Institute in the Manufacturing USA network, and they are a joint venture between the Department of Energy and the American Institute of Chemical Engineers. And their specialization is helping companies go directly from batch to mass production. And so we have a great relationship with Rapid. Through that relationship, we were able to win a $3.77 million Department of Commerce grant in March. And that will pay for the upscaling of our technology to mass production. And under that, we were able to afford to hire Southwest Research Institute in San Antonio to actually perform the work doing the upscaling. Southwest is a tremendously talented nonprofit research institute, and they have very deep expertise in electrochemistry, as well as developing some significant expertise in graphene itself. So those are the major milestones to date.
That was so helpful, and thank you for those questions. And I love that more are coming in, so we're going to keep going along this thread here. So, do you have an idea? You know, there are a number of graphene suppliers in the market. When will Avadain be able to supply graphene in larger quantities, say 100 pounds or even thousands of pounds? Any ballpark timeline for that?
Sure. The end state of our current project of upscaling the technology to mass production is the creation of the design for one production line that can manufacture 2 metric tons of graphene per year. That's 7 to 10 kilograms per day. That work will largely be done. It will be done in Q4 of 2023. And then after that, Rapid is going to do the actual design work so that we have the physical plant design that we will then license to different companies, which will then themselves create and manufacture the graphene. We will operate a pilot plant that SWRI will build, and we will move that plant to Memphis. So we will be creating large quantities of samples beginning in Q1 of 2024. But we believe at some point, probably around the second half of 2024, the first commercial scale production of our graphene flakes will be in the market.
Great. And somebody mentioned other suppliers, but it's probably helpful to do a competitive analysis here. What are some, what is the differentiation between Avadain and some of the other players in the space?
Sure. And I'd like to, if I could, try to share my screen because, can you enable me to share the screen, or is that?
I just did. Nope, okay. I just did. You're all set.
Okay, thanks. Thanks, Eric. Okay, I'm really bad at this.
You've got this, Brad.
I cannot find my presentation. All right, I'll just describe what I was going to try to show you.
You can take a moment if you think
No, it's fine. I'll try to describe it. And if what I'm saying is indecipherable, I'm sure you will let me know, and then I'll go back and try again.
Sounds like a plan.
So graphene is defined by the International Standards Organization as 10 atomic layers or less of graphite. That is 10 atomic layers or less. And the fewer the layers, generally, the better the quality of graphene. So when we divide the market, we say 10 as a horizontal line, 10 atomic layers is where there's a division between the upper half and the lower half of this diagram. 95% of the companies that claim to be selling graphene are above the 10 atomic layers. Some are above 1,000 atomic layers. So really, it has no bearing as graphene. It's just being used as a marketing term, graphene, but it's really not graphene. So 95% of the market is not even graphene. Then the second point on this is a vertical line of 30 microns. If it's 30 microns or smaller, the graphene doesn't have, it could be 10 atomic layers or less and 30 microns in size. It doesn't have the high mechanical strength of graphene. Graphene is 200 times stronger than steel. But if it's less than 30 microns or less, it's also brittle, so that it really can't be used as a substitute for structurally strong materials, or even for body armor for Army personnel. It just can't. It doesn't have those qualities. In fact, most of the materials that are graphene are about 1 square micron. And that makes it not very useful for a lot of applications. In addition to that, they have defects. Our graphene flakes are 55 square microns average up to 100 square microns. So they have the high mechanical strength. They're very large in comparison and possess all of the qualities that people want from graphene. So from a competitive analysis, 95% are above the 10 microns. Many of those are above 1,000 microns, so they're not really graphene. For those that are on the left, bottom left of the diagram, they're very small. They tend to have defects, not as useful as you need graphene to be. For us, we have no direct competitors in that part of the quadrant we're in. So 95% don't really have graphene at all. 5% have something that is graphene, but it's not got all the right qualities. And ours alone are in that quadrant for the mass production of graphene.
That's fantastic. And how large is the market for high quality graphene that Avadain makes?
I'm sorry, how large is the market?
Yes.
Okay.
Specifically for that high quality graphene.
Right. No one really knows. We're relatively certain it's $100 billion market. The question is, how many tons a year does that constitute? Some people say it's 100,000 metric tons. Some people say it's 200,000 metric tons. It might even be possible that it's a little less than 100,000, say 75,000 metric tons. No one is serving that market today, and one production line that we're designing will make 2 metric tons per year. And so when we look at the supply and the demand, you can see that it's an area that will have explosive growth, because it will take a long time, even with the largest chemical companies in the world, scaling up to meet that demand.
Got it. That's super helpful. And so what is the business model? How does Avadain make money?
Right. The business model we have is to license our technology, our manufacturing technology, to 3 categories of materials manufacturers. The first are advanced materials manufacturers who are already in the business of manufacturing materials. They have existing plant, they have people, they have expertise. they have customers, they have the infrastructure to support that. So I'm thinking of companies like DuPont or Dow or BASF, companies who are in the business of manufacturing advanced materials. So we believe that's one group. The second group are graphene applications companies. There are many companies who are trying to do very cool things with high value add with graphene, but just don't have access to the supply that they need. So we believe they will be a second bucket of licensees who will provide their own flakes for their own uses. And then the third group, which is really very exciting, are companies that have a mission critical need for graphene. And here I'm thinking of three different kinds of companies. The first would be tier one defense contractors. There are hundreds of uses for graphene in national security, everything from de-weighting drones to strengthening and putting armor on helicopters, to making antennas that are more efficient, will have greater range and consume less energy, to body armor to protect soldiers. There are literally hundreds of applications. And so tier one defense contractors will most likely want to have an assured supply of high quality graphene that they can control. So it makes sense for them to want to manufacture the graphene themselves. Second group would be electric vehicle battery makers. Everyone knows that the growth of electric vehicle batteries is skyrocketing. There's no secret to that. And there's a shortage of a lot of the materials that go into the making of those electric vehicle batteries. Graphene can make the batteries more efficient, last longer, and perform better. Those electric vehicle manufacturers will want to have access to graphene. And in fact, we've already begun a dialogue with one of them about licensing the technology to them so they can build the graphene for themselves. And then the final group of these mission critical companies are companies having to do with space exploration. We all know that the number one issue in launching vehicles into space is weight, right? Weight. So if we can de-weight those spacecraft that are going up, that makes it consume less fuel and it makes it much more reliable in sending them up. Also, when you have a model like SpaceX, they also want those vehicles to come back. Graphene is the best insulator against heat. It's also the strongest material, and it has virtually no weight. It's the lightest material ever discovered. So for spacecraft and rockets going into space, graphene will play an essential part. But even more importantly, for space exploration itself, currently the hulls of the spacecraft are very thin. They're very, very flimsy. And we all know space debris poses a tremendous problem to the International Space Station, spacecraft that are doing exploration. Here we can substitute graphene, which can be molded into the composite of the hull of the spacecraft to give it tremendous strength without adding weight. So graphene is harder than diamond. So we can give real protection to the spacecraft by using relatively small amounts of graphene. So that's an overview of the landscape for the companies that we envision will be licensees.
Oh yeah, no, that's super exciting. Every one of those applications, aerospace, military. I want to dig into specifically the aviation industry in just a moment. But before I do that, I want to remind everybody that we are fortunate to have the CEO of Avadain on the line here, Brad. We're discussing his company, and they're actively raising capital on the Netcapital platform. I'm adding another link to that into the chat. So after we wrap up here, do feel free to either click that link or go directly to netcapital.com/companies/Avadain, or go to netcapital.com and search Avadain, where you can learn more. And if you are so inclined, you can invest. Shameless plug in the middle of the programming there. All right. Let's get back to the questions that are coming in from the attendees. Thank you so much again for the attendees and your thoughtful questions. Please do continue to engage with the Q&A. We want to get to as many of these as possible and keep this interactive. What would you say 1 ton of graphene costs to make, and what kind of profit margin would there be? And I'm not sure, how specific you could be, but answer as much or as little of that question as you'd like to.
Sure. There are no sources for high quality graphene. And so we are aware of buyers who are willing to pay $100 per gram for the very high quality graphene that we are producing. So $100 per gram equates to $200 million per metric ton. Our licensing model will be based off of a percentage of that 200 million. And so let's just say hypothetically it was 10%. So each production line would generate $20 million of licensing revenue to Avadain. As we scale the number of producers, eventually the price per gram is going to drop. Just like with computer memory, when computer memory first came out, it was prohibitively expensive. And today it's very inexpensive. Well, we don't think that the price of graphene will ever be as low as the price of memory, but it is a vital material and will have significant value. So we see very early economic rents because of the price inelasticity of the demand for graphene. And then in terms of the cost of goods sold, until we're done with our upscaling work at SWRI, we won't know, but I'm thinking in the 10 to 15% range.
Thank you. And we were talking about all the different applications, and aerospace and aviation, I think, is so important. I want to dig a little deeper there. Have you been able to acquire contracts from the aviation industry, customers like Boeing or GE Aviation, anything like that?
Because of NDAs, we really can't tell you a lot right now, but we're not in a position to enter into any agreements until after the upscaling work is further along. Beginning this autumn, we're going to be providing samples to a very wide range of companies, and probably including the ones you've just mentioned. There are no guarantees, but probably. And that's the beginning of the dialogue of entering into agreements regarding their use of our flakes. It will require, in something like commercial aviation, it requires rigorous testing over a long period of time. So I would say that that's probably a longer play for us. Something like the use in supercapacitors and electric vehicle batteries is a more short-term play. That can be almost immediate.
That's fantastic. Yeah, long-term and short-term strategies alike. And we're experiencing, kind of a wholly unprecedented world that we live in now. Have you been able to ensure your product can withstand some of the supply chain disruptions that we've seen over the last couple of years with the global pandemic?
So the answer is yes. And the reason is that it's a very, very simple process from the electrochemical perspective. And most great inventions, by the way, are really simple once somebody invents it, right? Looking back on it, it's really simple, right? For us, there are only a very few ingredients that go into the process, and they're all fortunately environmentally friendly. There's graphite, which is a very common material. There's hydrogen gas, there's a conductive salt, polar solvents, and that's it. Electricity, sorry, it's electrochemistry, so there's electricity. So we don't see ourselves as being very vulnerable to the supply chain. Fortunately, we plan to manufacture here in the United States. And so for US industry, we hope that there won't be any supply chain disruptions.
No, that's fantastic. And you touched on something else that I really want to dig into as well, which is the kind of the environmental impact. So if we can dig into the manufacturing environmental impact, as well as there are conversations around graphene making the world cleaner, healthier, more prosperous place. So during the manufacturing process and once it's in the market, can we talk about the environmental implications?
Sure. The manufacturing process takes place in a machine that Southwest Research Institute is designing. It's not tremendously large. Think of it as like maybe 20 feet long, 10 feet wide, 8 feet tall. And it's really just the application of electricity in a certain controlled environment to separate the layers of the graphite. So, as complex as it is to get to the point of mass production, it's actually itself, when it's done, it's about controlling the process parameters, but it's a very straightforward application. Now, some people produce graphene sheets. It's a totally different kind of graphene. It has different uses. It doesn't really overlap with graphene flakes. But to do that, they have to use toxic chemicals on expensive materials with very difficult to control processing parameters. And at the end of the day, it produces toxic gases. That there's nothing like that here. What we're doing is very safe for the environment, and it's very safe for the people who are operating the process. Now, once we have the flakes, how does it make the world a cleaner, better, healthier, and more prosperous place? Well, we can use the graphene flakes in masks. We've partnered with a company called Flextrapower on the West Coast, which developed an N95 mask using graphene oxide. And that's, again, a very low quality kind of graphene material. They believe that they can achieve an N97, N98, or maybe even an N99 breathability with pure graphene, and to have an easier breathability. So Flextrapower is currently working in a project with us to develop that. Obviously, that makes the world healthier, especially in an era when there's no telling when the next COVID wave will come. In terms of water, as I mentioned earlier, researchers in Australia have patented and have demonstrated an ability to take salt water and convert it into fresh water using graphene as the filter medium. The shortage of water is one of the world's major environmental challenges. Having better access to mass quantities of fresh water can change the lives of hundreds of millions of people in drought-stricken Africa, in Asia, even here in the United States, in the Southwest and the West Coast, where water shortages are a real fact of life. So that when we have a situation of rising oceans from global warming and the melting of the polar ice caps, maybe there's a way here, led by the Australians, to take water, seawater, and convert that into fresh water so that people can use it.
We could pause on desalination through graphene. That's a pretty amazing application for sure. Continuing along here, we talked about some of your previous milestones, and you've been able to do quite a bit this short of time that you've had. But can you tell us about some of the next major milestones that you see on the horizon?
Absolutely. So the next major milestones are going to be applying for another federal grant later this year to test our graphene in a wide variety of electric vehicle batteries so that we can demonstrate the effectiveness, which helps to propel our licensing efforts. We are continuing to patent. We want to continue to file patents. We are going to be creating more samples through the process that Southwest Research Institute is using in a batch process this autumn, starting in maybe Q2 of next year, or certainly in Q3, from the mass production of the graphene. We're then designing the first the prototype plant that we will then be licensing. And hopefully in Q2 of 2024, we will be entering into our first license agreement. So those are the very short-term milestones that the team is focused on.
Absolutely. No, those are great. I want to welcome a couple of attendees who joined the Avadain family by investing through Netcapital. So I want to welcome those folks on. Love to see that real time. So you talked about the difference between the sheets and the flakes. Is this product just a coating, or can you make like sizable blocks of graphene?
So graphene is a 2D material. So you don't really make any product out of graphene. What you do is you add graphene to different products. So for example, if you want to, if you want a battery to have greater charge and discharge speed, you would take out the graphite that's currently used on the anode or the cathode, and you'd substitute pure graphene. Graphite is not a good electrical conductor. It certainly can withstand high heat, and it has other attributes, but it's not a good electrical conductor. Graphene is a nearly perfect conductor. So you would integrate the graphene into the anode or the cathode or both. In a supercapacitor, you would add graphene into the capacitance material. And when you do that, the rate of charge and discharge increases dramatically, and you're able to achieve 100% depth of discharge and 100% charge. And if you have rapid charging and discharging, it maintains its specific capacitance, unlike other materials which decline. So graphene is added to products, such as the composite material for an airplane, which we've discussed. You don't actually build a product out of graphene.
I think that was a very helpful explainer. I appreciate that. More questions coming in. Love it. Please keep it coming. How do flakes maintain material strength when they're embedded into a composite material?
Now we're getting into the realm of my colleagues on the science side. So I'll hazard my answer and then face the consequences tomorrow.
Yeah.
So a very small amount of graphene is used. They do have bonding effects. So the graphene bonds also with the graphene as well as the material around it. And so the idea is that you layer this in between the composite layers. And that is how it has the strength, the high mechanical strength, yet the flexibility of graphene.
Perfect. And again, you guys heard the big disclaimer with the massive asterisks, right? That was on the science side. So we can follow up on those conversations offline, but that felt like a satisfactory answer to me, being a non-scientist. In the event of patent infringement, this goes a little bit into your IP strategy. Would you defend them yourself? Because that can be costly and timely or time consuming.
Right. Well, I've been doing IP licensing for 15 years. So of course, along with IP licensing comes IP enforcement, because some people just won't take a license and nevertheless use your technology. So I have a 20-year track record with Fish & Richardson, the US's #1 IP law firm. For us, it's not a big deal using Fish & Richardson to go after a company that's infringing, but I guarantee you it's going to be a big deal for the company on the other side of that equation.
Yeah. Coming from the space intellectual property standpoint, Fish, undeniably one of the most powerful players in the space. It's great to have them on your team. I love this question. Why Reg CF? Why crowdfunding? Why let everyday folks in?
Well, there are probably as many answers to this question, and all of them are important. So let me just touch on a few, and then we can keep going if people want a deeper explanation. What we're trying to do is democratize graphene, right? We're not sitting here saying we're going to build manufacturing plants, we're going to control the space, we're going to command the price we want, and lots of people have said that's what we should do, but that's not what we want to do. We want to get it out there so it gets into as many products as quickly as possible. We want to see companies scaling up and see the world benefiting from our graphene. So we really want to democratize it. And in that vein, it makes a lot of sense to open up investing to average people. Accredited investors can afford to get into really transformational technologies like this. The average person really can't. So part of our mission of democratizing graphene is also making it available to everyday people. So that's one answer. There's a more factual nuts and bolts answer, and that is, so far we've had about 5.6 million in dilutive and non-dilutive capital injected into Avadain. And we've had VCs tell us that they'll put a $5 million valuation on our company if we want them to invest, right? Well, you know, we're not some startup by 20-year-olds in a graduate program in doing their first business transaction. We're not, okay? So that's ridiculous. And we've also had VCs tell us that we have to bootstrap until we have between $1 and $3 million of sales. Well, once we're starting to sell our graphene flake samples, we don't need to talk to anyone, right? We're going to cash flow very well. And so there, you know, we met the folks from Netcapital a while ago, and we took our time thinking about what the right strategy would be. And we decided to choose Netcapital because of the real focus on deep tech investments and deep tech companies. And we felt very comfortable with that. And I think once we break 500,000, it's going to be a rocket after that in our capital raise. And I think Netcapital is the right platform.
Love to hear that, Brad. I you know, they say in law school, don't ask questions you don't know the answer to. I broke that rule on that one, but I think it's just an important question to ask, and I do appreciate your candor on those answers. Let's transition a little bit to some of the financial prospects here. You mentioned cash flow positive. Do you have a timeline that you imagine or that you anticipate Avadain becoming cash flow positive?
Yes, we should be cash flow positive in 2024. We feel, you never can say never, but we feel pretty good about being cash flow positive in 2024. And our objective is to return our investors capital in 2025.
And on that note, what do you see as potential exits for investors? And again, we're just kind of theorizing here. There's no guarantees for sure.
Absolutely. So the first thing people think of is an IPO. This company is not really suited to an IPO. And the reason is that when valuations are put on an intellectual property-based company, they're based on a net present discount of future royalties. And then there's risk that's layered into that, you know, the market uncertainties. And so really we're betting against the company by doing an IPO, because we're only getting a discounted net present value rate. Whereas if we hung on to it, we would be likely to achieve all of that capital and return that capital to our investors. So an IPO, you never can rule it out, but it really doesn't make a lot of sense. More likely is that one of the very large companies, maybe a tech company, maybe an oil and gas company, would be interested in acquiring us in order to gain control over this strategic material. One can envision the likely players there, but at some point, and it should not be too far into the future, we see one of those companies wanting to step up and take control. And they will undoubtedly believe that they can grow the company better than we can. And, you know, maybe they can. When you have unlimited resources, you can do a lot of things. So that's what we see. And so what's the worst case? The worst case is that we achieve very lucrative recurring revenue from royalty agreements.
Certainly the end of the world there. We're getting close to the end here, so I'm going to give you a heads up. I love ending with closing remarks. I'm a traditionalist that way, so I'm giving you a heads up. At the end, I'm going to ask you why now is the perfect time to go to Netcapital and click that invest button. But before we get there, we have a couple more questions to get to. What is your commitment to keeping your investors informed of Avadain's journey?
This goes right along with the idea of democratizing graphene and democratizing the raise. This is one of the most common questions I have. I've met with quite a number of our investors. I am personally committed to making sure that investors know what's going on. We're going to issue quarterly updates via the blog and through email. We really want to keep those people informed. People who have something more to contribute, either from the technical side or from the finance and growth side, I'd like to also have more frequent conversations with them. And then, of course, annually we'll put out a statement on the company's achievements and prospects for the next year.
No, it's critically important, and I know you take that so seriously, so I'm glad we were able to get that question in. This actually might tie into your closing remarks, but I wanted to do a recap for some deal highlights. I saw some folks saying that they got in a little bit late. I know we experienced technical difficulties in the beginning, so I'm not sure if you want to tie it together to why now is the perfect time to invest, but if you could just kind of recap some of those real exciting deal highlights that we covered early in the conversation, I think that could be helpful.
Sure. Our offering is very unusual. In my 35 years in business, I've never really seen a company in the situation we're in. Why? The reason is that some of the world's, or most of the world's leading tech companies have been experimenting with graphene for years. There are more than 60,000 issued patents on the use of graphene to make products better or to introduce new products. So why hasn't graphene changed the world? The answer is simple. No one has been able to overcome the three obstacles to bringing the graphene revolution into reality: quality, quantity, and price. That's what Fraunhofer solved the problem of. The quality issue Fraunhofer discovered was the carbon-oxygen bond. During the exfoliation process, they were able to create an environment where that would not occur. Therefore, they overcame the quality problem. They also, by the use of electrochemical exfoliation and expansion, were able to make large flakes. So they solved the quality problem. My hat's off to them. They did a fantastic job. That ended in 2020. Now it's our responsibility to overcome the other two. The quantity issue, we're well on the way to overcoming that through the work of Rapid and Southwest Research Institute, as well as the good work of Sarah Rocher, our graphene scientist from Fraunhofer, who's now on our team. So the quantity issue we have pretty well in line. And in terms of price, the process of electrochemical exfoliation is inherently inexpensive. The most expensive input is electricity. And so the price issue is overcome by virtue of the fact that we're using electrochemical exfoliation expansion. So here, finally, is a way to meet the pent-up existing demand for graphene flakes. The Department of Defense has been looking for a source of high-quality graphene flakes for a long time. And I think based on some discussions we've had and ongoing discussions we're having, we can meet their need. In terms of industry, our flakes are proven to have the right qualities and we can meet that market demand. So the question then for us, tying this back together, is scaling up quickly enough. And that's where our licensing model comes from. And I should also mention that all of this is made possible to happen quickly because of the $3.77 million Department of Commerce grant we got, which is very generously paying for this. So when people invest in Netcapital, they're putting in the last dollars to make all of this happen and not the first dollars.
Well, Brad, I can't think of a better place to end than right there. Thank you so much for joining us as a panelist and describing what you've been able to build with Avadain, that you continue to build. I'd love to thank our participants for your thoughtful questions. Thank you so much for coming in and participating with the Q&A. Love to see one more investor come through real time that came from the live Q&A here. Welcome to the Avadain family. As always, the company that we were speaking with, Avadain, actively raising on the Netcapital platform. You can see a couple of links inside the chat there. You can go to netcapital.com/companies/Avadain, or go to netcapital.com and search Avadain. If you missed any of this conversation that we've been able to have, this will be uploaded to Netcapital's YouTube account. I'll go ahead and add a link to that into the chat as well. You can click that, recap anything that you might have missed. Of course, you share that with somebody else that you think might be interested in learning more about Avadain and potentially investing. So thank you again to our participants and our attendees. Thank you so much, Brad, for hanging out with me and answering my questions. It's always a pleasure.
It was my pleasure, Eric. Thanks to you and thanks to our audience. Thank you very much.
Take care, everyone.
Thank you. Bye-bye.